All right, let's go over the Euclidean algorithm. It's used to find the greatest common divisor from two positive integers. So we'll go over the overview, we'll move on to some of the code, and then the code will cover standard use and a recursive version. So to start with, the algorithm basically just whittles down the problem until it becomes a lot easier when we have a solution. So if you look at the first example here, we've got 270 divided by 192. We could do that by hand, but or brute force, but that would kind of really be a lot of work, especially if our numbers were a lot larger than this. So in this case, 270 divided by 192 is 1. We have a remainder of 78. But we can also look at that a different way. 270 is equal to 192 times 1 with a remainder of 78. Now, if we look at it that way, we can grab something from that. We can grab the second number, 192, and a remainder of 78. We can divide those. It's going to be 2 with a remainder of 36. Again, 192 divided by 78 is equivalent to 192 is also equal to 78 times 2 plus 36. So again, we'll grab our second number b, and then we'll grab the remainder. So we're going to move on to 78 divided by 36. It's going to equal 2 with a remainder of 6. Also look at that another way again. 78 is equal to 36 times 2 plus 6. And then once again, and for the last time here, we're going to grab our second number 36 and our remainder of 6. We're going to do 36 divided by 6, which is going to be 6, remainder of 0, or 36 equals 6 times 6 plus 0. Now in this case, one of our numbers is going to equal to 0, and that's how we know we're done. So the greatest common divisor of 270 and divided by 100, or 270 and 192, greatest common divisor is 6. All right, let's get into the code. All right, so the first thing I want to do is let's just go over what we expect to happen here, and then we'll derive our code from that. Okay, so the first thing we want is we know it's going to be called the Euclidean algorithm. All right, so let's say we want to divide the numbers by each other, i.e. a divided by b. The next thing we know, we want to repeat that using the whole divisor of b and the remainder of a divided by b. And we also say when a or b is equal to 0, return 1 with a positive integer. So basically, we're just going to divide a by b. We're going to take b as a whole divisor, and we're going to divide it by the remainder of a and b. And when a or b is equal to 0, we're going to return, if a is equal to 0, we're going to return b. And if b is equal to 0, we're going to return a. All right, first things first, let's code out a simple example using a while loop and a little more drawn out process, and then we'll refine it some, and then we'll move on to the recursive part of it. Let's create a function. Let's just call it Euclid algo. I'm going to take in a, take in b. And we're going to move on. We're going to do our while a and b. This will control our while loop, and that is the same thing as when a or b is equal to 0, we're going to kick out of here. So either a or 0 ends up being b, or a or b ends up being 0. We're going to exit our while loop. So let's start by temp a equals a, temp b equal b, a is going to equal temp b, and b is going to equal temp a modulo b. Now we should console log this out, and we'll go over how it worked. Let's just say we've got 270, 182. We're expecting this to reduce to 6. Obviously, it tested a version similar earlier. Nope, because we didn't do this. Okay, so we missed an important part. If not A, return B. And then if not B, return the opposite, A. Okay, let's test it. We got 6. So what we're doing here is, if we think back to the way we did it, we want the second number and then the remainder. So in this case, we're grabbing B as the second number, we're moving it to the first, and then our B, we're assigning it to the remainder of the original one that came in at that time. A little complicated, but if you look at the math, it starts to make a little bit of sense pretty quickly. Okay, so we ran it. Now, this is hideous, and we can get rid of it with a much cleaner syntax. So let's clean up a little bit better with the syntax. Let's say A comma B is going to equal B comma A modulo B. We just replaced 4 lines with 1 line. And once you start looking at this, this is a pretty clean way to read it. We have our same answer. So this is kind of just a simple while loop. Next, let's get into our recursive function. All right, recursive time. Let's call this a function recursive Euclid. Again, we're going to take an A, comma B. In this case, let's say if not A, return B. Apparently my cat Rocket decided to join me. If not B, return A. And then, if that doesn't work, well, if we don't catch it there, here's when we get to the recursive part. Let's call our recursive Euclid again, but instead of what we passed it before, let's pass it B, then A modulo B. So here we're going to pass it, we're going to call it again. So if none of them equals 0, we're going to get it down to this recurrence statement. And then we're going to pass it B as the first parameter, and then the remainder of A divided by B as the second parameter. Give this a shot. See how it goes. Recursive Euclid, let's pass the same numbers because we already know what we're looking for. And boom, both of them do 6. Just to kind of clarify that, comment that one out, and let's look at that again. And we got 6. So both of these accomplish the same thing. We accomplished the whole thing in 3 lines here. We got a couple extra here. I think it's debatable which one's more readable. Once you get comfortable with recursion, I find it very readable, but others may disagree. But I definitely think it's an algorithm worth exploring and learning more about. And I definitely appreciate you watching. Thanks.